Good morning, NDC. How are we all feeling today? Yes, come on, let's make some noise. Come a little closer, I'm not going to bite. So, thank you so much for making it to the opening of the conference and joining me. And particularly, I should say a big thank you given the topic of my talk, AI. I think we can all agree that AI has maybe been flogged a bit to death by this point. In fact, show of hands, who here is sick of hearing about AI? Yeah, I promise you this isn't a trick question. I specialize in this area, and I'm sick of hearing about AI. Sure, I'm really excited about the innovations in this area. We've seen some really cool advancements in machine learning and in neural networks in the last years. But what I'm tired of is how overblown and relentless the reporting in this area has been. Because let's be honest, it's been 3 years of headlines like this. Computers teach themselves, while we are getting no smarter. Computers mimic human intelligence. And the day may soon be here when computers will solve human problems too complex for people to cope with. But the thing is these headlines are not from the last 3 years. In fact, none of them are even from this century. The first one is from 1982, before I was even born, and I'm not that young. The second, from 1973. And the last one is from 1958, when my mother was still a child and before the Beatles were even a band. And you can tell this one comes from the 50s because it comes with bonus nightmare fuel illustrations. And these headlines were just a small fraction of those that I found when I searched newspaper archives for the term artificial intelligence. And all of them felt eerily familiar. Predictions that professions would soon be automated by AI because we would soon have algorithms that could do difficult technical work. And of course, that old chestnut, the scientists afraid of their creation getting away from them. But how can this be? We've been told by everyone that we're in the middle of the AI revolution. So how can we be seeing headlines from almost 70 years ago that look like they could have been written yesterday? Well, the truth is this is not the AI revolution. It's not the first. It's not even the second. It's the third. And the first one started in 1956. Our current AI era has in fact been going a lot longer than you might realize. It certainly started before 2022. Some people peg the start as far back as 1986. I think that's a little optimistic. I'd peg it closer to 2006 and 2012. And the previous eras that we've seen are now historically known as AI summers. And they both follow a very similar pattern. There was some sort of shift in technology that made the development of a new form of AI possible. And initially, advancements in this AI were very rapid. And this built a lot of excitement, and people started predicting that we would soon have artificial general intelligence, or AGI. This led to a lot of funding pouring in and a lot of excitement in the market. But inevitably, the technology plateaued, the technology couldn't live up to the expectations, and a lot of disappointment set in. The funding dried up, and we entered what's called an AI winter. Now, why do we see these boom-bust cycles when it comes to AI development? And perhaps a more salient question, are we in the middle of the third AI summer? And is another AI winter around the corner? Well, to answer that question, we need to go back to the beginning of modern AI. And that starts, as many things in computer sciences do, with Alan Turing. So Turing had been doing work in the 1930s on programmable machines. And this culminated with the development of the Turing machine in 1936. Now, this and his work on code breaking led Turing to believe that it may be possible to program a machine to behave intelligently. So Turing's work spread throughout the research community. It didn't just spread to computer scientists as well, it spread to engineers, it spread to mathematicians, to neuroscientists and psychologists. And this led to people believing that it may be possible to mechanize things like problem solving and reasoning, and therefore it may be possible to build a machine that could simulate the human brain. And this led to the publication of 3 of the seminal works in AI, and interestingly, they were all actually published in the same year, in 1943. The first of these has the very catchy title of A Logical Calculus of the Ideas Immanent in Nervous Activity. And in this paper, the authors set out how you might build an artificial nervous system by building a network of small logical units that are later called artificial neurons. So if you've ever studied modern neural networks, this will sound very familiar, and indeed, this is a foundational work in modern deep learning. But at this time, the work that was being done in this area was called connectionism. The next is the nature of explanation. In this book, Kenneth Craig lays out his theory that the human mind works through the formation of a huge amount of small mental models. And these mental models are used to make sense of what's happening in the world and make predictions. And this was the foundational work in a field called symbolism, which is the idea that you can automate human cognition by building these small mental models using logical rules. And the final work is behavior, purpose, and teleology. And this paper tries to explain what it means for a system to have purpose, the way that that system can adjust and modify its behavior based on how close to a goal it is. And this became a foundational work in an area called cybernetics. And this is the study of how systems modify their behavior based on feedback loops. So you might have noticed, none of these fields are called AI. And that's because the term artificial intelligence didn't exist yet. Instead, we had these 3 interconnected fields. We had people doing a huge variety of different research, from neuroscientific work to try and simulate the human brain, to work making these cute robotic turtles, to chess playing programs. But that changed pretty quickly, because cybernetics soon caught the attention of funding bodies. And that's because cybernetics has a focus on goal-directed behavior. So it's pretty obvious how you can apply it to things like industry, but more importantly, to the military. Remember, the Cold War was just starting, so anything that might give the US a military edge was considered interesting. And this dominance of cybernetics was solidified in 1948 when the very unfortunately named Norbert Wiener published his book. Now, this book here was an academic bestseller, and it really cemented Wiener's reputation as the foremost researcher in this new field of thinking machines. And all of this laid the groundwork for the first AI summer. And this started with a young associate professor of mathematics at Dartmouth called John McCarthy. Now, it's 1955, and McCarthy is feeling impatient about what he sees as slow progress in this field of thinking machines. So he went to the university with a proposal to fund a workshop at the university the next year. And in his proposal, he said the following: "We think that a significant advance can be made if a carefully selected group of scientists work on the problem of thinking machines together for a summer." So this is where the term AI summer comes from. It was based on the fact that the first significant gathering was a summer workshop. Now, the hopes going into this workshop were staggering. They really thought by getting together a group of the right thinkers, the right scientists for this 2-month period, that they'd be able to build machines that could understand language, form concepts, and solve complex problems. Yes, they really thought they could do all of that in 2 months. So the next time your PM is giving you a hard time about estimation, remember this. But what to call this workshop? Well, the logical thing to call it would be a cybernetics workshop. We've just seen how dominant that paradigm was. But McCarthy didn't care for cybernetics. He was a symbolist. He loved the crisp, discrete logic that this approach took. But perhaps much more importantly, McCarthy did not like Norbert Wiener, and I can't entirely say that I blame him. Wiener was notorious for having a difficult personality, for being possessive of his ideas, for being emotionally volatile and socially awkward. One of his colleagues said of him, He spoke many languages, but was not easy to understand in any of them. He was rather notorious for turning up to any symposium with cybernetics in the name, falling asleep and loudly snoring throughout the talk, and then waking up to ask an awkward question at the end. So how to hold this workshop without Weiner coming? Well, what about calling it something completely new? And as such, McCarthy coined the term artificial intelligence, something broad enough to encompass any automated computing system, but different enough from cybernetics to break away from Weiner. So as you can see, AI started as a marketing term. So over time, the legend of the Dartmouth workshop has really built up in AI mythology. But in truth, it wasn't really that productive, especially given the really high hopes they'd had going into it. So one of the attendees said the following: the research project wasn't very suggestive. The main things of value: wrote and got report reproduced, very important for an academic. Met some interesting people in the field. Got an idea of how poor most thought in this field is. Damn, no one's nasty like an academic is. So what ended up happening at this workshop? Well, of the total 20 attendees, only 3 actually stayed the whole time. And what they ended up doing was a bunch of talks and informal discussions. And they couldn't even agree on a project that they wanted to work on together. There's a very funny story of them arguing about whether solving chess is a worthy problem, and the arguments for and the arguments against. So unsurprisingly, only 3 publications came out of this workshop. But luckily for the symbolists, one of these papers ended up being so significant that it changed the direction of this new field of AI from cybernetics to symbolism. So the logic theorist was a symbolist AI program that was designed to solve foundational mathematical proofs. And it was the first program to show some degree of generalization. So it's considered the first true AI program. And the success of this program really excited a lot of people. And it got the public interested in seeing how this symbolist approach to AI could take them forward. So on the back of the logic theorist, the symbolist got the first AI summer started. The logic theorist was followed up by the even more powerful general problem solver, a program that was designed to solve any problem, as long as it was formulated as a well-formed formula. The Samuel checkers playing program, pictured here, was able to beat a checkers grandmaster in 1962. And foundational algorithms for pathfinding and search were created. Things were also advancing in natural language processing. Who here has heard of ELIZA? Yeah, only a few of you? You should go and find it. It's still available online. But it was a very cute little program that came out of the first AI summer, which is designed to simulate a Rogerian psychotherapist. Tell me how you feel. But more significant at the time was the very unpronounceable Schödlu. And this allowed users to interact with blocks in a blocks world. So basically, they could use natural language commands. These were parsed by a language parser, and it allowed them to do things like move the blocks, stack them, and ask about them. And you can see an example of a command that a user has entered here: pick up a big red block, and it has successfully parsed that. So all of this success got people excited, and they started thinking, well, if we can solve these specific problems, maybe AGI is around the corner. And it made sense with the symbolist approach to intelligence. Their thinking was that everything was based on these small mental models that humans had. So if they could replicate enough of them using formal logic, then human intelligence was within reach. Now, the optimism was staggering. One of the creators of the logic theory said in 1960, technologically, machines will be capable within 20 years of doing any work that a man can do. And this was not an isolated belief. Many key researchers in this area thought that human-level intelligence was just around the corner. So things were humming along nicely, but they really took off in 1963 because the Soviet Union launched the Sputnik satellite. Now, it is difficult to overstate the significance of this event. Sputnik was the first structure that made it to space. And this made the US government really afraid that the Soviet Union was outstripping them technologically. So in response, DARPA, which is the research branch of the US military, decided to go all in on AI research. So they started with Project Mac. This was a $2 million a year investment in MIT's AI lab, and that was continued until the end of the 1960s. And they followed up with similar investments at institutions like Stanford and Carnegie Mellon. So by the end of the 1960s, DARPA had invested the equivalent in today's money of hundreds of millions of dollars in AI research. So the symbolists were having a lot of success and funding and attention, but what was happening to the connectionists during this time? Well, they actually had a stunning early victory with the development of Frank Rosenblatt's perceptron. Now, the perceptron was developed in 1958, and it is considered the first true artificial neural network. So Rosenblatt was able to train it to be able to distinguish between cards with a mark on the left-hand side versus cards with a mark on the right-hand side. And this got a lot of excitement. This was a machine that could teach itself just based on a data set, and it led to headlines like this: nearest yet to human life. But the thing was, at the time, it was only possible to build single-layer neural networks, and there's only so much that these can learn. So then when Rosenblatt tried to apply this to a more difficult problem, it couldn't generalize. And similar connectionist projects also had these generalization problems. And at this point, neural networks had a target on their back. So a number of symbolists really didn't like connectionist research, and the most vocal of these was Marvin Minsky. So Minsky actually started as a connectionist, but after the Dartmouth workshop, he switched to symbolism. And he truly believed that connectionism was a dead end for work on intelligence. So throughout the 1960s, Minsky leveled a lot of criticism at connectionist research, but he dealt his death blow in 1969 with the publication of his and Samuel Pappert's book, Perceptrons. So in this book, they were able to mathematically demonstrate that these single-layer neural networks weren't able to do something as basic as XOR. This is something that, of course, that any basic reasoning needs, and of course, which symbolist AI can do very easily. So Minsky's work, particularly perceptrons, spread the idea that neural networks were just a dead end. They weren't worthy of further research, and they were particularly not worthy of all that nice funding that could better go to symbolist AI. Frank Rosenblatt had an untimely death the next year, and this, coupled with Minsky's criticisms, meant that neural networks faded into the background, at least, of course, for now. But by the mid-60s, the cracks were also showing for symbolists. So one of the first warning signs was machine translation. This had been of huge interest for the US government because they wanted to be able to automatically intercept messages written in Russian and translate them to English. So let's see how this project went with the symbolist approach. So we have this sentence here in Russian, and the ideal translation would be something like, mammals, dogs, mice, rats, guinea pigs were used in these experiments. So the first of these translations is okay, but it does translate mice as meath, and it does this weird garbled literal translation of guinea pig, which is sea pig in Russian. The second is significantly worse, and it gives us this really weird English Cyrillic mashup, which is a translation of experiment. And then the final one is just complete garbage. So as you can imagine, DARPA was extremely disappointed with these results, and they ended up cutting all funding to machine translation in 1966. But as the decade went on, other symbolist projects were not doing that much better. The general problem solver collapsed when it was faced with messy real-world problems. Schödler was great at understanding natural language in the block world, but outside of that, it was useless. And then the final end to the first AI summer came in 1973 with the publication of the Lighthill Report. So James Lighthill was commissioned by the UK government to assess the state of AI. And he found it was not living up to expectations, that it was great at toy problems but nothing else, and that ultimately it was not worth further funding. Almost overnight, funding on both sides of the Atlantic was slashed. John McCarthy even flew to London to debate James Livehill live on the BBC, but it was too late. The funding dried up, research slowed down, and we officially entered the first AI winter. But research doesn't stop during AI winters. It never does. It just slows down. And one of the threads that took us from the first AI summer into the second was Lisp. You know that programming language with all the parentheses? Yeah, that one, Lisp. So let's go back to the first AI summer. It's 1958, and the symbolists are dreaming of more and more complex ideas that they want to implement. But the programming languages of the time, like BASIC and Fortran, were not equipped to deal with symbolist structures. So John McCarthy wrote one that was, and that was Lisp. So now with Lisp, the symbolists had a powerful language that could natively work with symbolist structures. And this allowed them to build all this foundational work that we saw in the first AI summer. So this, in fact, makes Lisp the first AI programming language. And although I'm a Pythonista, I have to concede this defeat. But one of the trade-offs that Lisp has, it's very flexible, but it's also very memory intensive. And what that meant was, memory was phenomenally expensive at that time. So trying to run Lisp programs, especially as experiments, on the machines that the AI researchers had available in the 1960s was painfully slow. So by 1973, a researcher called Richard Greenblatt at MIT's AI lab decided to build a custom-built Lisp machine. So the first of these machines, Cons, was created by hacking a general-purpose processor and making its memory management more efficient for Lisp. And with this success, he then followed it up with a more effective version called KDAR. And word of these KDAR machines actually started spreading throughout AI research labs. And they were like, can we have one? Greenblatt's like, sure. So he started building them at $50,000 a pop. That is $250,000 in today's money. And you thought M4 Macs were expensive. They are still expensive. So by 1979, word of these super cool Lisp machines started spreading, and it got back to Russell Nofsky. Now, Nofsky was the previous head of MIT's AI lab, and he came to Greenblatt with a proposal. Why don't you do this full time? We can make a business where we sell these Lisp machines. So Greenblatt, the thing about him is he was not motivated by money. He was one of the creators of hacker culture. And what he really valued was pushing machines to their limits and being able to share that information openly. So he was amenable to starting this business, but only if they could bootstrap it, creating custom-built machines on demand for hackers by hackers. Now, this was not what Nofsky had in mind at all. He wanted to make a profit. He wanted to make a formal business. And as you can imagine, they could not agree. And it was actually a very acrimonious split, and Nofsky left and founded his own Lisp machine company called Symbolic. And actually, many members of the lab went with him. Now, those that stayed behind did end up founding a Lisp machine company called Lisp Machines, Inc., or LMI. And those of you who know anything about computing history will not be surprised to learn that one of the members of the lab that ended up staying with Greenblatt was Richard Stallman. And he was furious about what Nofsky had done. He considered it a betrayal and a stab in the back. But anyway, they did found their Lisp machine company, and LMI was founded on Greenblatt's principles. They focused on engineering excellence, and they custom-built machines. But let's leave these warring Lisp machine companies for now, and we're going to go back into the first AI summer. And we're going to look at the second thread that ended up taking us into the second AI summer. And that was a specific type of symbolic AI called expert systems. Now, as the name suggests, expert systems are designed to emulate human expertise. And they have two components. The first is a knowledge base. This is basically a bunch of information that's extracted from a human expert. And the second is an inference engine, which creates rules that use that knowledge to make predictions. And as an aside, the people whose job it was to create the knowledge bases in those days was knowledge engineers, which goes to show that almost every AI revolution manages to come up with its own form of bullshit engineering. Finally, I got a chuckle from you. So we saw some early successful expert systems. One of the first was Mycin, which was designed to emulate doctors, and another was Dendril, which was designed to emulate the expertise of chemists. But one of the first applied successes came with an expert system called Prospector, which is a geology expert system. And this managed to predict where a valuable deposit of a rare mineral was, something that human experts hadn't been able to find. So while Prospector was never productionized, it really showed the potential of this new form of AI. So we have a hot new form of AI, and we have the specialist hardware to run it. So the second AI summer roared into life in 1980. Throughout the first half of the 1980s, 2/3 of Fortune 500 companies were trying to use expert systems in their daily business activities, and at least one had a stunning success. A company called DEC used an expert system called XCon to be able to predict which of the computer components they sold would satisfy a customer's requirements. And by 1985, it was saving them $25 million a year. This is a huge success. So on the back of stories like this, expert systems proliferated. They started creating expert systems from everything to predict the flow of toxic gases to the outcomes of legal cases. Universities, of course, were offering expert systems AI courses, and funding was starting to come in from both the public and private sectors. And then DARPA got involved again. We had another Sputnik moment in this AI summer, and this time it was from Japan. In 1981, the Japanese government launched the 5th Generation Computer Systems Project. It was an attempt to drive forward progress in hardware, in human-machine interactions, and of course, in AI. So this spooked the US government. Japan had had a post-war economic miracle and was now the second most powerful economy in the world. And the US was worried that they might be overtaken technologically. So the reporting in the US on the 5th Generation project was rather hysterical. Although the Japanese government had committed $500 million to the project, numbers in the US were reported as high as $4 billion. People were also reporting that AI-powered robots were starting to take people's jobs in Japan. So in response, DARPA committed $1 billion to the development of expert systems and other AI. Now, DARPA's hopes this time around were even more optimistic than during the first summer. They really thought AGI was around the corner this time. They thought that they could create an expert system or some other form of AI that could think, feel, and learn just like a human, with a degree of integration that would rival the human brain. And reporting in the media followed suit. Some reporting was a little more muted, perhaps remembering the lessons from the last AI summer, but others were repeating that AGI was just around the corner. And of course, in this summer, we have a focus on expert systems. So there was many articles saying that professional jobs would soon be replaced by AI within the next 10 years. I even found an article from 1981 saying that a company was working on an expert system to replace software developers. The more things change, the more they stay the same. And of course, all of this lovely AI was running off the back of Lisp machines. Now, things never got better between symbolics and LMI's approach just wasn't working. They were not getting market share, they were not competitive. So they started saying things like symbolics was unethical, they'd violated hacker culture, they even broke the law. But none of this was true, and Symbolic's approach spoke for itself. It went from basically no revenue in 1981 to well over $100 million in 1986, with a healthy profit. And then, of course, money started being dumped in new, exciting AI startups with aggressively 80s names like Inference Corp and Syntelligence. Now, many of these AI startups really didn't have a clear business plan or use case, But they were associated with illustrious institutions like Symbolics and the MIT AI Lab. So they got overvalued funding rounds on the back of this alone. Now, by the mid-'80s, excitement about AI, market speculation, and investment was out of control. A 1984 report found that private companies were spending $64 million a year on expert systems, and this was projected to grow at least 50% a year to the end of the decade. Remember this prediction. And you can see the sort of reporting that was everywhere at the time. People were saying that expert systems growth in so many different areas would just continue to grow and grow to the end of the 80s and beyond. But by 1987, the cracks were starting to show. And that's because expert systems were very difficult to build, even harder to modify, and extremely brittle for most use cases. Now, let's think about what an expert system involves. And we can see an example here with a defense expert system. This one rule in this defense system requires 3 different pieces of knowledge from the knowledge base and 4 different rules, just to make this one prediction. You can imagine how many rules you need like this and how accurate they need to be if you want to use it for something like defense. And that's to say nothing of how hard it is to construct the knowledge base. The knowledge base is comprised of human expertise, and this is often very difficult to extract in a comprehensive fashion. There are things we use as experts like rules of thumb and implicit information we don't even recognize we're using. And this is just super, super difficult to capture in a knowledge base. But the final blow came in 1987 with the development of Unix workstations. Now, at the time, Unix was free to universities, so a lot of software was coming out of universities, including that to build and run Lisp programs. Moreover, semiconductor technology at the time was advancing, and we were seeing that basically by this stage, Unix workstations were fast enough to nullify any benefits of buying a specific Lisp machine. And this is to say nothing of the price point. The cheapest machine that Symbolics offered was $40,000, compared to a Sun Unix workstation at $14,000. Symbolics went from an $11 million profit in 1986 to a $25 million loss in 1987. As the Cold War cooled and expert systems didn't live up to the hype, DARPA started withdrawing their funding again. And many companies were left with expensive Lisp machines they had no use for. So that leads us to where we are now. And it leads us back to the question we asked at the beginning. Are we in the third AI summer? And is another AI winter around the corner? I would love to give you a concrete answer to that, but if I had that kind of predictive ability, I'd be cashing in on NVIDIA stocks while the going's still good. What I can offer you is a comparison between what's happening now and what happened in the first and second AI summers, and I'll let you make up your own mind. So let's first revisit what each of these eras was doing. In the first AI summer, there was so much naivety. They just didn't understand the problem space because it was brand new. And so they really underestimated how difficult it was going to be to mechanize human cognition. They tried to solve for this in the second AI summer by focusing on specialization, but they still underestimated how difficult it would be to fully capture human expertise. And our third era is characterized by scaling, building big enough models using big enough data sets with the hope that it leads to generalization. So let's see how our current scaling approach is going. So I'm going to start with private investment. And here we can see 4 large tech companies that are building what's called frontier models. These are these state-of-the-art generative AI models that you see talked about everywhere. As an aside, I really wanted to include information for OpenAI and Anthropic, but I just couldn't find reliable numbers. But we'll take these companies as an indication. This year alone, it's September. The year's not over. And these numbers are about a month out of date. These companies have spent $65, $80, $100 billion on generative AI. Now, this is serious money, and it really rivals, maybe even outpaces what we saw in previous AI summers. But of course, we're talking about private companies. Their goal is to eventually make a profit on the back of this. So let's see how that's going. Ooh, I hope for that reaction. AI capex for these companies is exceeding revenue at least 6-fold. In the case of some of these companies, it's more than 20-fold. This is a really worrying picture if we're talking about profitable, viable AI models. So let's now talk about public spending. And this AI summer actually had its own Sputnik moment. So in 2017, Google hosted a competition between China's KJ, who was the world's best Go player at the time, and their AlphaGo model. And AlphaGo actually narrowly won. And this sent a shockwave through China. Go is a deeply respected cultural game, and it was beaten by an AI, but worse, it was beaten by an American AI. So as such, the Chinese government pivoted their spending priorities towards AI, announcing in 2018, by 2030, we shall make artificial intelligence theory, technology, and application at the world's leading level. Now, of course, this spooked America, and they started investing heavily in basic AI and semiconductor research. And it seems that the Americans' fear of China's winning this race may have been realized in January of this year with the release of the DeepSeek models, which showed that you can train state-of-the-art LLMs at a fraction of the cost that had been invested in models so far. Now, this is yet another geopolitical race. We saw this in the first summer with the Soviet Union. We saw it in the second with Japan. And it's fueled by fears that your country will essentially be beaten by another country to all-powerful AI. Now, these fears drive a lot of investment in AI, whether or not the return is actually certain. Now let's talk about hardware. NVIDIA, of course, has been a big winner in the current AI era. Their revenue has grown 500% in the last 2 years, and pretty much all of this has come from spending on data centers for training and running huge generative AI models. In fact, if we look at this as a share of revenue over time, we can see that share of revenue from data centers has gone from 32% in 2020 to an eye-watering 89% currently. And a really important thing to understand about this investment in data centers is that it's an ongoing expense for companies that want to be training frontier models, because once processors are more than 2 years old, they're no longer considered powerful enough to train state-of-the-art models. So this might seem to put NVIDIA in a really nice position. They've got continued growth that's going to come from the development of generative models and an ongoing revenue stream. But we can draw clear parallels to what happened to symbolics in the second AI summer. In 1986, symbolics was flying high based on growth projections for strong interest in expert systems through to the end of the decade. And in 1986, Russell Nofsky even said, "We don't see a leveling off in the near term. There is an almost unlimited range of possibilities." And yet, just the next year, the company was in financial freefall as demand for expert systems collapsed. NVIDIA's growth is similarly fragile. We might think right now there's going to be a continued demand and growth for generative AI, but we just don't know if that's the case. And part of the reason that we have this assumption that we're just going to keep growing and growing with generative AI is because we have an underlying assumption that these models are just going to get better and better till they approach something like human-level performance, perhaps even AGI. And again, this is exactly what happened in the first and second AI summers. Now, in this AI era, these predictions started early, and they started coming from people core to the industry. In March of 2023, Microsoft Research released a paper stating that the newly released GPT-4 was showing sparks of AGI. The same year, Dario Amodei, the CEO of Anthropic, stated that we would have AGI in 2 to 3 years, and now that that doesn't seem to be panning out, he said this year that we're going to have artificial superintelligence by 2027. Now, you've been with me. We've all lived through this together, and we've seen so many of these predictions. And I think most of you will probably agree with me, they just don't seem to be panning out. And as time goes on and investment in this technology grows and grows, we can see a lot of pressure is building on these companies to come up with some sort of breakthrough. And if we think about why these models just don't seem to be living up to expectations, that's because, just like all the models that came before them in the first and second AI summers that looked so promising, they have limitations. In the case of generative AI models, these are just gigantic machine learning models which were trained to do one specific thing. They were never trained to be general AI, and they really aren't. And I feel that the market is starting to recognize this. So let's focus on LLMs for a second, because they've really been at this core of this AGI debate. So I've given a lot of talks in the last few years. If you've come to any of my talks, you may be sick of me saying this, but LLMs are not AGI, and I go into that in a lot more detail in some of my other talks, so if you want to see those, I'm going to be sharing a link at the end. But for now, let me just focus on two unresolved limitations that LLMs have that prevent them making that leap. The first are hallucinations. These are a massive problem with the use of LLMs, and some researchers believe that these may actually be an unsolvable problem. It's not an overall, shared consensus, but it does seem that at least fixing them is going to be extremely difficult, if not impossible. The second is work that's been coming out in the past year about the true reasoning ability of LLMs. There seems to be increasing evidence that LLMs aren't actually reasoning, they're pattern matching. And when you present them with really complex problems that involve multiple steps, they collapse. They can't perform with these really difficult problems. So if we think about what we would need an LLM to do in order to be the core of some sort of independent intelligence, we need it to be able to take in messy, real-world, complicated instructions, parse it correctly, and then give us an accurate output. And right now, they just can't do that. And it doesn't seem to matter how much time and investment we invest in them. They don't seem to be able to make that leap. And again, this is the same thing that happened to their predecessors in the first and second AI summers. And then perhaps the most damning piece of evidence happened a couple of weeks ago. Sam Altman, the CEO of OpenAI, took a group of journalists to dinner, and he said the following: "When bubbles happen, smart people get overexcited about a kernel of truth. Are we in a phase where investors as a whole are overexcited about AI? My opinion is yes." Now, if the CEO of the most highly valued AI company in the world says that we might be in a bubble, we might be in a bubble. Another AI winter might be around the corner. So what does this mean? At this point, you might be feeling a little frustrated, like, what is the point of investing in AI research if we get these boom-bust cycles? And yes, that is part of AI summers. They have two sides, and we've just spent around 45 minutes looking at one of those sides. Things that didn't work out, things that didn't live up to the hype. But they have another side as well. A lot of valuable technology that actually works for specific use cases comes out of AI summers. And much of it is so ubiquitous and well accepted, we no longer think of it as AI. So one of these is the A-star algorithm. This is a pathfinding algorithm that was invented in 1968 during the first AI summer, and it's still widely used. And if you want a taste of how it's still used in video games, you should definitely attend my friend Layla Porter's talk today about the forgotten AI of video games. But this is also the algorithm that Google uses to plot your directions in Google Maps. So it's very powerful, and it's had massive staying power. Another are semantic networks. These were invented in the first AI summer, but really gained popularity during the second. So one of the most successful semantic networks projects is WordNet. This was started in 1985, and it's an attempt to try to map the semantic relationship between words in a language. And WordNet is still used today. I've used it. Grammarly uses it to correctly parse sentences. And then we have hidden Markov models. These were invented in the second AI summer, and they're still an important algorithm, especially in speech recognition. In fact, the early Siri models used hidden Markov models. And even if our current AI era ends up being a winter, it doesn't mean it was a waste. Quite the opposite. Our current AI era has been characterized by an abundance of data and algorithms designed to learn from it. And we have seen such exciting advancements in machine learning, in computer vision, and of course, in my beloved natural language processing. I've worked as a data scientist for many years, and my colleagues and I have built real-world products that solve real-world problems using these algorithms. They're very useful. And even LLMs, if we end up in an AI winter, they're not going anywhere. They're probably going to end up being the biggest target of AI disillusionment, but they're the most powerful models we've ever had for working with text data, and they're going to continue to stick around until we have a successor for them. LLMs are really quite amazing models when you apply them to the right use case. They've allowed us to solve problems I didn't even think were possible when I started in this field. So I'm going to offer a few predictions for what might happen to LLMs if we end up in an AI winter. I believe that frontier models, they're probably not going to be trained in the same way, but they're probably going to stick around, and they will be used as the core of agentic applications, but they're going to have much narrower use cases, and we're going to need to have humans with expertise in the loop of those workflows. We're going to continue to use smaller large language models for specific natural language tasks. We've been doing this for years now. And we're going to continue to see a growth in focal models. These are smaller, specialized LLMs trained to do very specific tasks, like my own company's Melon model for code completion. And I have to thank my friend Michelle Frost for inventing that term, focal models. So as we walk through our current AI era, whether it's between overblown hype or increasing disillusionment, keep in mind that we have been here before, and we're very likely going to be here again. But also keep in mind we still do live in exciting times. Boundaries are being pushed in technology. It's just we're not at AGI yet. Thank you very much. You are a wonderful audience. If you want to grab my slides, the resources, and also other talks I've done, please go to this QR code. It'll take you to a GitHub repo. Here are my socials if you want to keep in touch, and I'll be around for most of the conference. Thank you very much.